Hey guys, welcome back. This is going to be our last video for Similarity before we start our next unit over right triangles, which is probably one of my favorite units I get to do all year. So it's a long unit, but it'll be really fun. So I want to go ahead and go over 3 problems that were the most missed problems from a quiz that I gave last year. So I decided not to give the quiz this year, but still, we can still benefit from the problems that people messed up last year. And you're going to see some similar problems on the test, and they're probably going to be the same problems you guys are going to mess up on the test with too. So it'd be really good if we go over these 3 problems before you do the practice test. Hopefully you can figure them out on the practice test, figure out what mistakes people are making, and then we'll be good to go. So on this one we have 2 triangles. Now I know they are going to be similar to each other. If I look here, let me choose a good color. Alright, so if I look here, they have the same angle over here. If this was like angle A or something, is congruent to itself by the reflexive property. Also, the other 2 angles are the same because they're both right angles. So I know these triangles are similar, so their sides must be proportional. So you're tempted to set up the proportion 4 goes to x just as 12 goes to 9, right? But that's not correct, and about 71% of my students miss this one because that's exactly what they did. So you have to be really careful. We got 2 triangles. We have the small blue triangle and we have the big triangle, which is the red one. Now this 9 is the extension. It's the part that's extending past the original 12. So if we look at the whole length of the red side here, it's going to be 12 plus the 9, which is altogether going to be 21. I know, really tricky. So that's why we're going over these together, right? So 4 goes to 4 goes to x, just as 12, the small one from the blue triangle, goes to 21, which is going to be the big one from the whole thing. Not just the extension, but the whole thing. So be careful. Alright, next thing we can do is we can actually reduce. So on this one, I'm going to reduce this. It's going to be 1 and 3, and then I could reduce that if I wanted to, and technically that would be 1 and 7, right? Alrighty, so 1 and 7. I don't think I reduced on this part here though, so I ended up with, let's see, 3x. Yeah, so 3x is equal to 21. Then I divide and I end up with x is equal to 7. So either way you want to do it, that's it. Alright, so number 2, similar issue, actually the exact same issue. So see if you can figure this one out, right? Alright, so we've got a side splitting theorem, so the angles are going to be the same. All 3 of the angles are the same. They're all similar triangles. You got small triangle, medium triangle, big triangle, right? X is going to be the part on the big triangle. They're telling us the extension from the first 4 to the next one is another 4, and then the last part is extended by 3. So we have our middle blue triangle, which is 10, and the bottom length is going to be 4 plus 4, which is 8. So 10 goes to 8, just as the big side x goes to the big length here, which altogether is going to be 11. We add all those together. Alright, before I cross multiply, I can reduce. So this is going to be, what, 5 and 4. And then cross multiply, I get 4x is equal to 55. Divide by 4. Both sides, you're going to have to put in the calculator, but we're going to end up with 13.75. So 66.4% of my students missed that one. They probably said that 10 goes to x just as 4 goes to 3, and that's not it. Alright, next one. This one's kind of interesting because we have 2 right angles here. So we could do side angle side, side angle side. So if I set up this, we got 2 triangles also. If I set up the smallest triangle, the smallest side is 4, and then the smallest side on the bigger triangle is 6. So the 4 goes to 6, just as the medium side on the small one of 6 goes to the medium side on the small one, which is 9. Okay, so this is side angle side, side angle side is what we're doing. Well, when I cross multiply these, I get 36 is equal to 36. So I know that these are actually similar. Now that I know the 2 triangles are similar, it's just rotated, by the way. Kind of cool. Let's finish setting up the extended proportion. So I have small, medium to large, right? 4 to 6 to 8 is going to be 6 to 9 to x. So the last part, I just need to cross multiply here. You can reduce here. You can do 2/3 before you do anything else. And then when I cross multiply, I'm going to get 2 times x, which is 2x. Oh, apparently I didn't reduce. That's fine. And then 9 times 8, which is 72. Divide these by 6. Might have to put that in the calculator, but you should get, what, 12? Yeah, x is equal to 12. Alright, so what about angle, angle, and the third angles theorem? Alright, so we saw this with our constructions. Depending on where you put C here, this is still allowed to grow or to get smaller. But if they have the same angles at all times, these 2 triangles will be similar, meaning their angles are the same, their sides are proportional. It's kind of like the classic case of similarities using angle. Then we have side, side, side. So we can prove it with side, side, side if all the sides are proportional. So one way we can do it is by setting up an extended proportion. The easiest way, honestly, if you can see it, the smallest one of 6 goes to the smallest one of 18. What are we multiplying by? Well, times 3. And then check the other ones. The median one of 9 times 3 is 27. Okay. The longest of 12 times 3 is 36. Yeah, so we do have a scale factor. They're all growing by the same proportion. Our scale factors are image divided by pre-image, which would be 18 divided by 6, which is times 3. In case it's not obvious, sometimes it's a fraction. The ratio is going to be 6 to 18, which reduces down to 1 to 3. Notice the relationship between 1 and 3 and 3. It's just the, the second part divided by the first part. Anyway, you can also check it by setting up an extended proportion, which I recommend, like we did on number 3, going smallest to greatest and smallest to greatest one. So 6 goes to the 18, right? The medium goes with the medium. So 6, 9, 12, 18, 27, 36. Then you just have to cross multiply. But on this one, you can actually reduce them all to 1/3. Yeah, so they're all, it's a European 3, 1. They're all 1/3, so they're all the same. All right, side, angle, side. So the importance about the location of the angle is it's included in between two sides. So we know this angle here, angle A, is going to be the same angle for both of these triangles. And if they don't tell us these lines are parallel, we can't do side splitting and other angles, right? So we need to see if 4 goes to 8, just as the other including side of 6 goes to 12. Well, if you look at those, the extension is just going to be 2 times the original one. And so clearly, I mean, times 2 times 2, these two are going to be proportional. Now you could set it up if you're not sure. So 4 goes to 8, just as 6 goes to 12. When we cross multiply, we end up with what, 48 is equal to 48. So we're good. Now that I know that they're similar, I want to solve for x. Now you got to be really careful because x is not the extension, right? The 4 and the 8 are extensions from the original one. But if we look at the big triangle, which would be like this blue triangle here, the blue links here, we add those together. So 4 plus 8, when we add those together, is going to give us somewhere, oh, it's hiding. There it is. Okay, when we add those together, it's going to give us 12. And when we add these together, it's going to give us 18. Okay, so if we have the small length here of 3 goes to the big length of x. So, or okay, sorry, 4 goes to the whole thing of 12, just as a small length of 3 goes to the x. So you do have to add those together when you're doing the whole thing. The other thing is, if you look here, the 3 is the same as this 3. Now the extension would be proportional, and if we were saying the extension was 2 times the original one, then 2 times the original one would be 6, and we add those together, we get x is equal to 9. That's totally valid and super stinking cool. If you can see, all the red parts are the same proportions, and if we put them together, it would be another similar triangle. What? That is so cool. Look at that. Check it out. So that green triangle is similar to the red triangle. I know, that's so awesome. But the extended proportions are just its own like separate thing, okay? So if we're looking at the big triangle, the blue one, we need to do the big blue dimensions. So 4, the small one on the green triangle, goes to, oh, it's like small, medium, large. Like the green's a small one, then the red is the medium sized one, and then the blue is the large one. That's so cool. All right, so 4 goes to 12, just as 3, the small one, goes to x. When we cross multiply, you'll end up with 9, I believe, on this one. So we get 4x is equal to 36. When we divide by 4, we get x is equal to 9. Sure enough. Fun stuff. Enjoyed that. Side splitting theorem. Now, on side splitting theorem, we're going to have corresponding angles that are congruent. The corresponding angles up here will be congruent as well, and this one's congruent to itself. So if we have another line that's parallel to one of the sides, then it'll split the other 2 adjacent sides proportionally, essentially. So the extension parts here are going to be proportional to the other non-extensions, I guess, the other parts there. So AB goes to BC just as AD goes to DE. So they split each other proportionally because, again, they're going to be 2 similar triangles. Now, the extensions are proportional, but it's like they're their own little triangle up here added on to the original part here. So don't make that mistake. It's like the 5th time I've told you about that, right? Okay, triangle, angle, bisectors. And yet some people still miss it on the test. All right, triangle, angle, bisector. That's why I'm here. All right, so if we have an angle bisector, and a triangle, it cuts the opposite side in proportions of the other two sides. So the green sides will be proportional to the green side will be proportional to the blue sides. So 8 goes to x just as 12 goes to 6. And if you notice here, the 12 and the 6, that's times 2, right? So, or divided by 2. So the same thing's going to happen here. It's going to cut it in the same proportion where we're dividing it by 2. So half of that should be 4. And sure enough, it is. When we cross multiply, we can reduce first, which I think is what I'm going to do here. Oh, actually, let me reduce that. That's going to be 1/2, and then half of that's going to be 4. Okay, so x is going to simply be equal to, so x times 1 is equal to 4 times 1, which is 4. So x is 4, and sure enough, it is. And as you notice the patterns here, the angle bisector is cutting the green side, which added up 12, by the way, into proportions of the other two blue sides, which were basically 2 to 1. And so it cuts it 2 to 1, which is 8 to 4, which is kind of cool. Alright, so that was it. 11 minutes to review everything that we've talked about in Similarity. So it's pretty fast if you ask me. Thanks for tagging along. Let's go ahead and get started on the assignment number 5. So we're going to do all the tricky ones together, basically. So number 5 is tricky. If we tried setting up a proportion on this one, we see, well, 2 goes to 4, just as 3 goes to 6. So you're thinking, oh yeah, it's just times 2 times 2. So sure enough, this has to be similar. But check again, we don't have all three sides, so we're not using side, side, side. We're trying to do side included angle side. But the angle they give us here is not in between the sides. We don't know what that angle is. Now, if they told us this was an isosceles triangle, then we could say, okay, so that has to be 70 and we're Gucci, right? But they didn't, so we actually can't prove these are similar. This would be angle side, side, which is the donkey postulate, a money sign, which doesn't work because it's ambiguous. I could draw the exact same thing but with an obtuse triangle and it would still have the same proportional sides as this one. So it doesn't work. So are they similar? No. The postulate we were trying to use was side angle side though. And again, why side angle side? Because one of them was side angle side. I don't know. I should have put it non-applicable because it wasn't one. Because they didn't actually match up. Alright, next one. Angles are the same here. I see an angle. I don't see another angle. I don't see any parallel lines. So it's not like I can do alternate interior or vertical angles or anything like that. So this is going to be side angle side. It's the postulate we're using, right? So I got side angle side, side angle side. So the smallest one for this triangle is 3. And the smallest one for the other one is 9. So 3 goes to 9, just as the largest one for the right triangle is the triangle on the right is 9, and the largest one for the triangle on the left is 27. Okay, now we can reduce if we want. You also notice, hey, these are the same fraction. They're 1 and 3, 1/3 as well. Okay, so I'm good. Are they similar? Yes, because they have the same proportions. 14, I got 3 sides. Now this one's a little tricky because technically we've got vertical angles in the middle. So we could prove this with side angle side just using these two sides. Then the smallest side, smaller side of 4, because that's actually the smallest. Smaller side of 4 goes with the smaller side of 12. So I would say 4 goes to 12, just as the largest side of 5 goes to the largest side of 15. And whenever I cross multiply those, they're both the same fraction, 1/3, 1/3, right? So they would be similar, and we could prove it with side angle side. But because we have all three sides, I'm going to go ahead and prove it with all three sides. So the smallest one is 3 and 1/3, and the smallest side over here is 10. And if I cross multiply those, you'll want to put that on the calculator, but it's basically the same thing. It's 1/3, 1/3, 1/3. So yes, they're similar. The postulate we use, technically you could have used either side, 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 or side angle side. But I did side, side, side on the answer bank. That's why I wanted to do it with you. All right, angle bisector, right? Cuts the angle. If it cuts the angle in half, it's going to bisect or cut the opposite side in proportions of the other two sides. So x goes to 7, just as 16 goes to 6. I can't reduce anything vertically except here. I can reduce that as 8 and 3, right? So take 2 out of both of them. Okay, so 3 times x, or 3x, is equal to 8 times 7, which is 56, divided by 3, and you get x is equal to a decimal, a repeating decimal, so 18 and 2/3. Alright, last one I'm going to do with you. Wow, we're going real fast. I love it. There's nothing new to teach you. It's just all review. Alright, we're going to prove that the triangles that are in an isosceles trapezoid. Now, if you remember the isosceles trapezoid, no. non-isosceles trapezoid, any trapezoid, are going to be similar. So this is similar to this one, and this one is similar to this one. And it was kind of cool because it kind of looked like it. It's just like a shrunken down version. That one's just like blown up. And this non-isosceles trap. So this isn't the one with the baby daddy rectangle. We had a trap on the side. Unfortunately, I know the drama never ends. All right, so we have angle DAC. DAC is this thing right here. Is congruent to angle ACB. ACB. Okay. Okay, those are congruent. Why? Well, if this is a trapezoid, that means I know that these lines are parallel to each other. So those are what kind of angles? Angle pairs of alternate interior, right? So those are our alternate interior angles, so they're congruent. Next one we have AED is congruent to BEC. In other words, the angles in the middle are the same. That's because they are vertical angles. Then they're saying the triangles. This triangle is similar to that triangle because they have two angles that are the same, so that's angle-angle similarity. That was easy. So those angles are going to be similar, just one's a shrunken down version of the other one, which is kind of cool. All right, then they're saying the sides are proportional. So this side is proportional to this side, just as this side is proportional to that side. Now, they're not necessarily going to be congruent. Now, if this was an isosceles trapezoid, meaning if this side was congruent to this side because it had a baby daddy of a rectangle from the side trap, you get the idea, then they would be congruent and these would be congruent as well. But right now it's like it's allowed to shift to the side or shift to the other side, which means this side is proportional to this side, just as this side is proportional to that side, which is kind of cool. And it's flipped, and we know that because this angle corresponds with that angle. So again, it's flipped, like rotated. So cool. Okay, so the sides are proportional, basically. Then they say that AEB is going to be congruent to that. So those angles are the same because, again, they're vertical angles. So then, so corresponding sides are proportional, vertical angles. So then that means this triangle is congruent to that, or not congruent, but similar to that triangle as well because their sides are proportional. We just said that on the other two triangles, right? And their angles, including angles, are going to be congruent as well. So they are similar by side, angle, side, which is fabulous. So whenever we have a trapezoid, the diagonals form two pairs, not congruent triangles, unless it's going to be an isosceles trap, but two pairs of similar triangles. Fascinating. How cool. Geometry is so much fun. All right, so if you have any questions, let me know. We'll do a practice test tomorrow, whenever that is, and then whenever you come back in person, make sure you have all of your homework done, because the first day back in person, whether it's Monday or Thursday, we will be taking the test, and then the second day back, we'll be playing a game. So good stuff coming up. Looking forward to it. I'll see you guys then. Let me know if you have any questions.